So in this video, we learn how to sketch the graph of an absolute value. In the previous video, I think you learned how to change an absolute value function to a piecewise function, right? So now let's have an example. For example, I want to sketch the graph of x plus absolute value of x. The first step would be changing this function to a piecewise function. As I explained before, we'll focus on the absolute value only, and then we will add x to it. So absolute value of x, as you already know, is x when x is larger than or equal to 0, and negative x as x is less than 0. By adding x to it, we'll have x plus x, which is 2x for x larger than or equal to 0, and 0 for x less than 0. Now, just focus on this green row. I'm going to write it here. Y equals 2x, and this is the restriction associated to that. And now I need to sketch this one. So as you know, y equals 2x is a linear function. Y-intercept is 0, it passes through the origin, and you know that slope is 2. So it means 1 right, 2 up. So this is the graph of y equals 2x. However, we have this restriction, x larger than or equal to 0. So we know that in the first and fourth quadrants, x is larger than or equal to 0. Therefore, this is the graph that we keep, and we erase the rest of that. Likewise, now I'm going to ask you to focus on this row. I'm going to write it here at the bottom of the screen. Y equals 0 for x less than 0. Y equals 0 is the x-axis. So the x-axis is I'm going to make it red. However, we do not need the entire x-axis because we have restriction here, which is x less than 0. Obviously, this part of the x-axis has x less than 0. Therefore, we need to erase the other part. There we go. What remains here, that red one, is the graph of y or f of x equals x plus the absolute value of x. So let's have another example. F of x equals absolute value of x over x. So absolute value of x can be written as x larger than or equal to 0, or negative x as x is less than 0. Now we need to divide by x. So we'll get 1 when x is larger than 0, and negative 1 when x is less than 0. Since x is at the denominator, x cannot be 0 because, you know, 0 is a non-permissible value for this function, or you can say 0 is not in the domain because denominator can't be 0. Therefore, I'm going to erase everywhere that I wrote x equals 0. Okay, now focus on the first row. The first row indicates y equals 1, which is a horizontal line. However, we don't need the entire y equals 1. We need a portion of that that associated to x larger than 0. So y equals 1 is a horizontal line, and we need to keep the part of this function that has positive x value. So x larger than 0 obviously is here, because as I said before, in the first and fourth quadrants x is positive. Therefore, I need to erase this part. Now, if you look at the second row, what you see is y equals -1, which is another horizontal line. And we keep the part of this line which is in the third or second quadrant. So y equals -1 is this line, and when x is less than 0, we keep this portion. Now I'm going to erase this one, and what remains is the graph of absolute value of x over x. Let's quickly have the third example. Okay, so all we need to focus on is the yellow part, which is absolute value of x minus 1. So y equals the absolute value. Let me start with the absolute value. The absolute value of x minus 1 is a piecewise function. X minus 1 as x is larger than or equal to 1, or negative x minus 1 as x is less than 1. All we need to do is multiplying everything by 2 and then subtract 1 from both equations. So therefore, y becomes, I multiply by 2 and then subtract 1. Likewise, I multiply by 2, then subtract 1. And let's simplify this as much as we can. So it becomes 2x minus 3, and here negative 2x plus 1. Okay, now we are ready to sketch the first row, which is y equals 2x minus 3. So the y-intercept is negative 3, and the slope is 2, which means 1 right, 2 up, roughly here. So which part of this line should I keep? So the condition or the restriction that we have here is x larger than or equal to 1. This is why I draw the line x equals 1 here. This is line x equals 1. So since x is larger than or equal to 1, I'll keep what I see at the right side of x equals 1. So therefore, I will keep this part, which indicates x larger than or equal to 1. And then I'm going to erase the rest of that. Okay, now we'll draw this one, the second row, which is negative 2x plus 1 with the y-intercept of 1 and slope of negative 2, which means 1 right, 2 down. That meets with the other line here. However, the restriction here is x less than 1. It means we need to keep the left side of the gray line, x equals 1. So therefore, I will keep this, and then I erase the other part. We don't need x equals 1 to be here, but just for the sake of accuracy and seeing where the 1 is, I'll keep x equals 1 as the line of symmetry here. But this is not a part of the graph. And let's do the last example of today. So y equals x absolute value of x minus 2. So absolute value of x minus 2 simply becomes x minus 2 when x is larger than or equal to 2, and negative x plus 2 as x is less than 2. By multiplying by x, we'll get x squared minus 2x for x larger than or equal to 2, negative x squared plus 2x for x less than 2. As usual, we start with the blue row, which is y equals x squared minus 2x, which is a quadratic function. To sketch this quadratic function, we need vertex, and the way that we get vertex is negative b over 2a which is negative 2 over 2 times a, which is 2. So x of vertex is 1. Let's plug in x and get y. Once you plug in x here, y becomes 1 minus 2, which is negative 1. Therefore, the vertex has the coordinates of 1 and negative 1. So 1 and negative 1 is the coordinates of the vertex. Since the coefficient of x squared is positive, this quadratic function opens up. And also because the leading coefficient is 1, we can claim that 1 left, 1 right, function goes up by 1. So function goes here. If you have any trouble understanding how to sketch the graph of quadratic functions, you can watch my videos about quadratic functions. So this is the graph of y equals x squared minus 2x. So where is x equals 2? Because the restriction says we need to keep x larger than or equal to 2. Let me sketch the gray line, x equals 2. So 2 is here. This is x equals 2. Since the restriction x equals 2 indicates the right side of this gray line, I need to keep the right side only. And then I'm going to erase the rest of that. Also, let's do the second one, which is y equals negative x squared plus 2x. The vertex would be x equals negative b over 2a. Again, negative b, which is 2 over 2 times negative 1, so which is 1. If you plug in x1, y is going to be 1. So therefore, vertex in this case would be 1 and 1. So 1 and 1 is here. The leading coefficient is negative 1. It shows two things. First of all, it shows that the quadratic function opens down. Secondly, it shows that one right and one left function drops by 1. So therefore, this is the graph of negative x squared plus 2x. The restriction attached to this function is x less than 2, so it means we need to keep the left side of the gray line, which is x equals 2. So we keep this one and we erase the rest of that. Yeah, this is the graph of y equals x, absolute value of x minus 2. You can always check your work with graphing calculators. For example, Desmos is one of the best. I'm going to show you that if we sketch the graph of this function with a graphing calculator, it gives us the same thing. So x, absolute value of x minus 2, as you see, this is exact same thing that we sketched. Look at this graph and look at this one. They are exactly the same. So thank you for watching. You need more practice. I will have another video about sketching the graph of absolute value. We'll go even deeper to this concept because absolute value is one of the main pillars of like functions and derivative and limit in calculus, and we need to learn this function um, profoundly. Yeah, see you soon with another video.